This video is on systems of nonlinear equations. We are going to solve each of these systems by graphing them. So in order to graph them, we need to have them in slope-intercept form or into y equals format so that we can graph them. On each of our graphs, we need to have our x and our y axis labeled. So we're going to put x and y on all of our graphs on each of our x and y axes. So there are 4 on here. We're going to put x and y on all 4 of them. So now we need to graph these, make sure that they are in y equals. This first one is in y equals. I'm going to graph the first one in pink. So I'm going to graph that -8 is my y-intercept, and my slope is 6 over 5. So 1, 2, 3, 4, 5, 6, up 6, right 5. I'm going to do it again, up 6, 1, 2, 3, 4, 5, 6, right 5. This is as far as I can go. Now, because I'm drawing a line here, I want to make it as accurate as possible. Because I only have 3 coordinates, I'm going to use a ruler or a straight edge just so that I can make these nice and correct. Now, this is a line, so it does go on forever, so I'm going to put arrows on them. And then I'm going to graph my second one in blue. So we have also a line, and it is in slope-intercept form. So I have my y-intercept is -1, my slope is -1/5, so down 1, right 5, down 1, right 5, up 1, left 5, up 1, left 5. I do want to graph the entire line, not just the coordinate. So I connect these with a straight edge, and I find where these 2 graphs cross. These 2 graphs do cross once at this location. That coordinate is at 5, -2. So our solution is 5, -2. X is 5, y is -2. On the next one, same thing. We want to have it in, since this is linear and this linear, we want it in slope-intercept form. So I'm going to rewrite them. This will turn into y equals. I'm going to have to subtract the x and then divide by 6. So I'll have -x over 6. Then with the 42, I'll have to divide by 6, so that'll be a +7. So I have y-intercept of 7, the slope of -1, 6. So down 1, right 6. And go up 1, left 6. And I have my pink line by connecting them with a straight edge. Next is the blue one. I need to put this in the slope-intercept form as well, so this will be y equals. I'm going to have to subtract the 5x, but then divide by a -6. So a -5 divided by a -6 is a +5/6 x. Then we have -6 for the y-intercept divided by the -6 on the y, so that'll be a +1. So my y-intercept is 1. I have a slope of 5 over 6, so 1, 2, 3, 4, 5, 6. Cannot go up any further. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So then I can connect these blue coordinates. And the graphs do cross at this one location. At this coordinate right here. That coordinate is at x value of 6, y value of 6. So our coordinate is 6, 6. That is our solution. The next example is a quadratic. We still need to get the y by itself. So the first thing we need to do is subtract the 5, but then we'll divide by the negative. So y is equal to, this part's already over here, we're going to divide that by a negative, so it'll be negative parentheses x minus 3 parentheses squared. This 5 would have been subtracted, and then it's going to be divided by a negative, so it'll end up being a +5. This is a quadratic. Our vertex is going to be at +3, +5, so 3, 5. Then if I do 4 minus 3 is 1, 1 squared is 1. negative 1 plus 5 is 4. So it'll be at 4, 4. Do the same thing with the 5. This will become a 2. This will become a 4. It'll be 5 minus 4. It'll be a 1. Do the same thing with the 6. This will become a 3. Squared is 9. So this will be 5 minus 9, which is negative 4. And then I can mirror those across the axis of symmetry. And then I can connect these as best as possible. The next one is the blue, which is already in the correct format. The y-intercept is going to be, or the vertex is 0, 0. If I plug in 1, 1 squared is 1 times 2 is 2. So it'll be 1, 2. That pink does not go through 1, 2. 2 will be 8, because 2 squared is 4 times 2 is 8. And I can mirror these. Connect them. These two parabolas are not intersecting each other. There is no intersection. Therefore, our answer is no solution. These two are not intersecting each other. This next example, again, we've got to put them into the y equals. I need to subtract the 5 and then also divide by a negative. So y will equal to. This part's already on this side. I'm going to divide that by negative, so the outside will be a negative. Square root of x plus 2. We would have subtracted the 5 and then divided by the negative. So this will end up becoming a positive 5 again. Our vertex, or our starting point, is going to be at that negative 2, positive 5. So negative 2, positive 5. Okay, and I want to find the values that will give me perfect squares in here. So negative 2 plus 2 gave me 0. I need a 1. Negative 1 plus 2 gives me a 1. So at negative 1, square root negative would give me a positive 1. That'd be 1. Negative 1 plus 5 is 4. So negative 1, 4. The next perfect square would be a 4. So I would want 2 plus 2 gives me the 4. So at 2, this would become 4. Square root of 4 is 2. That becomes a negative 2. 5 minus 2 is 3. So it would be at 2, 3. The next perfect square is 9. So 7 plus 2 gives me 9. So my x value is going to be 7. So then this would become 9. Square root of 9 is 3. This entire thing becomes negative 3. So it's really 5 minus 3. So that would be at 7, 2. And then this would be our graph. If we connect these. And yes, you can graph that and get coordinates and graph coordinates. The blue, we have to put this in the correct format. Got to subtract the 8. So that's the only thing we have to do. So it will be y equals 5 over 3 absolute value of x minus 1 absolute value minus 8. This is absolute value, so you need to know your slope and then your vertex. Our vertex is 1, negative 8. So 1, negative 8. Our slope is 5 over 3. So we're going to go to the right. We're going to go up 5. 1, 2, 3, 4, 5. Right 3. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. We're going to do the same thing going the other way. We're going to still go up, but this time we're going to go left. So up 5, 1, 2, 3. Left 3. Up 5, left 3. We're basically just mirroring these coordinates again over that axis of symmetry. So we're going to go up 5, and we're going to go left 3. And we're going to connect our points to make it an absolute value. So again, we're going to stop it at the vertex. We're not going to go further than that. We're going to graph it the other way as well. Again, stopping it at the vertex. These two graphs do intersect once at this one coordinate here. that coordinate is at 7, 2. So our answer is 7, 2.